Hi everyone, this is my final year project transferring waste plastic into a usable fuel. Aim of my research to solve the twin problem of environmental pollution due to plastic and the need for an alternative fuel source in Sri Lanka. These are the key wording of my aim. Environmental pollution due to plastic, need for an alternative fuel source. Introduction. Global consumption of crude oil. Basically, crude oil used for transportation, energy production and some other applications. Higher usage of crude oil reduce the crude oil storage and also increase the energy reduction. In other hand, crude oil used for produce the plastic for human consumption. Plastic have become waste after it used. So that waste plastic have become one of the major reasons for environmental pollution. So that through my research I am trying to give solution for these two problems, converting waste plastic into the usable fuel source. Sources of plastic. The majority of most commonly used plastic are derived from the following chemicals: ethylene, propylene, butadiene, benzene. These chemicals are in turn derived from naphtha obtained during the petroleum refining process. Both plastic and petroleum derived fuel are hydrocarbon that contain the element of carbon and hydrogen. The difference between them is that plastic molecules have longer carbon chains than those in LPG, petroleum and diesel fuel. Therefore, it is possible to convert waste plastic into a fuel. By adapting chemical processes such as pyrolysis can be used to safely convert waste plastic into the hydrocarbon that can be used to produce the transportation. When the cracking temperature achieved long carbon chain break into the small carbon chain. Case study 1. Main purpose of doing case study 1 was to identify plastic type that can be used to produce the usable fuel. Following 6 phases were adapted for the execution of the study 1. Preparation of reactor. An empty AC gas container was used to produce the reactor. Several changes were done to the empty container when it was converted to the reactor as shown in the figure. Due to the higher functionality of reactor, there was no sufficient cooling from cooperative from the natural air. Because of that extra cooling system was added to the system which was operated by the water. To overcome this problem, selection of suitable power source. Several power sources were tested to identify most suitable power source. During the testing, it was observed that normal wood and LPG gas failed to provide the required temperature for plastic cracking. Coconut shell were able to provide the required temperature. Hence, the polka to agroliber was used to power generation for pyrolysis unit. However, it was unable to perform as it is because of the clay body of the polka to agroliber cracked when higher heat was applied. Therefore, to avoid this, aluminium plate was attached to the body and it restricted further cracking on the body. The fuel production technology flowchart. First, separate the waste plastic from the landfills. Separate the plastic according to the type of plastic. Wash the plastic to remove the other waste substances attached with the plastic. Drain to remove the water. Cut into the small particles. Carrying out the pyrolysis process. Store and received fuels. Then stored fuel can be used. Energy the results. The numerical values are not much important of this stage. So this is the result. (500 gram of plastic sample). The PETE and PVC were not pyrolyzed. This is the graphical representation of the result. These are the samples of outputs. Main purpose of carrying out study 1 was to identify plastic type that can be used to produce usable fuel. There are 6 types of plastic undergone through the testing. According to the observation, PETE and PVC were not suitable to produce the fuel. Generally, PETE recycle efficiently at the recycling centers, so it is best to recycle PETE in traditional manner. PVC pyrolysis release large amount of chlorine and it had to corrode reactor. In addition, it polluted the environmental. Figure shows the corroded reactor after PVC pyrolysis process. Therefore, according to the result observed, HDPE, LDPE, PP and PS plastic types were able to convert to the fuel successfully through the pyrolysis process. Case study. Usually waste plastic available in waste dump site as a mixture, so it can be separated according to the plastic type and continue pyrolysis process one by one as done in case study 1. It called as method 1. Pyrolysis process can be done for mixture except PVC and PETE. It called as method 2. Main purpose of doing case study 2 was to identify best method from the above 2 that can be applicable in Sri Lanka. Several researchers have done to identify available waste plastic composition in the waste dump site. However, unfortunately there is no research related to the Sri Lanka. As an option, the Asian plastic waste composition was used to prepare mixture sample. According to the study 1, using PVC and PETE for pyrolysis is unsuitable. So, PVC, PETE and others were removed from the raw waste plastic sample before preparing the waste plastic mixture for pyrolysis. Therefore, composition of two plastic mixtures change according to this figure, which can be pyrolysis. HDPE, LDPE, PP, PS waste plastic were separated from the waste plastic raw material. A 500 grams of sample mixture plastic was prepared using this table, which was prepared according to the given graph. The following table shows the composition of the final products for melting of single batch. Testing was done to same as the result. Producer's liquid fuel yield presentation was 70.5 A black solid residue percentage was 14% and light gas combustion was 15.5 and 6.3 kilogram of coconut shell were spent for fire generation. By using 500 gram of mixture, we can get an output of 460 milliliter of liquid fuel WPPOM and 70 gram of residue. The following factors were considered identify best option: produce liquid quantity, produce residue quantity, produce energy, required energy to cracking. We can prove that method 2 sterilizing mixture of 4 types of plastic sample 2, 3, 5 and 6 according to the waste generation rate is the most suitable method which can be used to produce usable fuel by waste plastic sterilizing. Case study 3. Main purpose of the study was identify available fuel type which can be compared to the WPPOM renewable fuel procedure. Comparing running time using petrol engine, comparing running time using kerosene engine, comparing running time using diesel engine, comparing physicalities. 3 types of petrol, kerosene and diesel engine were used to conduct these tests. 50cc 2-stroke petrol engine, 4.2 horsepower Kubota kerosene engine, 5 horsepower Petter diesel engine. Physical properties. Physical properties also much deeper with the other fuels. WPPOM is not suitable for using petrol engine as the petrol engine was unable to start by using WPPOM. Produce leak. It was possible to use WPPOM for kerosene engine when even though it did not give 100% performance when compared to the kerosene. Calculated efficiency of WPPOM is in kerosene engine was about 86%. In addition, the physical properties were not very different from the kerosene. It was able to use WPPOM for diesel engine even though it did not give the 100% performance when compared to the diesel. Calculated efficiency of WPPOM in diesel engine was about 94%. In addition, the physical properties were also not differ from the diesel. The main purpose of study 4 was identify application of WPPOM to the Sri Lankan. According to the worldwide survey conducted in year 2010, approximately 1.59 million metric ton of mismanaged plastic waste was annually generated in Sri Lanka. It was 5% of the global mismanagement plastic waste. According to that, take the fifth place. WPPOM for power generation in Sri Lanka. Kerosene. Application of kerosene is very limited. Local diesel consumption was 1696.74 thousand ton and has a capability of refining only 441% 545 That means 27% in local refining centers. Others were imported as a refining diesel. Therefore, it is possible to use WPPOM instead of the auto diesel. It will reduce requirement of imported diesel. 1.59 million metric ton of mismanaged waste plastic waste were available in Sri Lanka waste dump site. According to the study, 72.4% of waste plastic were able to undergo through pyrolysis process. Table is showing the capability of waste plastic transferred into the usable fuel. That means WPPOM 811.57 thousand ton, gas 178.43 thousand ton, residue 161.16 thousand tons. Auto diesel consumption. So according to the chart, 811.57 thousand tons of WPPOM can be produced using 1.59 metric ton of mismanaged plastic. It was approximately 47% of total auto diesel consumption in Sri Lanka and 67% of total imported diesel. So by doing that, it is possible to reduce imported auto diesel from 1199.17 thousand ton up to 387.6 thousand ton. $178.43 thousand tons of light gas was produced when generated in WPPOM. In addition, it was observed that gas capable to igniting during the testing. Technology of collecting gas is little costly, and so the gas was unable to test it by this research. However, if it will be capable to use instead of LP gas, it will recover 96% of annual LP gas consumption. According to this study, 27.22% of plastic waste was unable to use for pyrolysis process. In addition, study 2 confirmed 14% of residue was generated by the pyrolysis. When consider mismanaged waste plastic in year 2010, it can be residue up to 62% by weight.